Hello engineers, welcome back. In this video, we're going to start a new topic called templates in C++. I hope you're ready. Let's get started. So we're going to see these topics today. We'll see what templates are. We will discuss what are function templates. We'll discuss what are class templates. And then we'll see some benefits of when and why we need to use these templates. Okay. So let's get started. So what are templates? So as we know, C++ is a strongly typed language, right? Which means it is type sensitive. Or you can say strongly typed, which means the data types of variables and the return types of functions, classes, class variables, class methods, everything, wherever we are using variables, we need to be very specific in declaring those variables, using those variables, and dealing with their memory management and things like that, right? But because of this, we are kind of limiting our capabilities. So that's where templates come in. With templates, we can write generic code. For different data types. So imagine I have an add function which takes in two parameters x comma y, and then it simply returns the result of x plus y, right? Now in C++, I need to mention what is the data type of x, what is the data type of y, and what is the data type of the return value, right? Let's say I'm putting int here, int here, int here. Return type would be int. Now, if I want to reuse the same function, let's say for double, I will have to rewrite it, right? I'll have to write like this: double x, double y, and then return x plus y, right? And if I want to add two characters, I have to rewrite the whole thing again. This time I will take character x, character y, return x plus y, right? I will have to do the same operation on different data types, and to do that I need to write three different functions, right? Let's see all this in code. So I've created a new file under C++ folder, and let's see how we can do this. Let's say we have a function called add. Let's say we are doing integer addition. So we are returning x plus y. Now let's see what happens here. I have two variables, x equal to 5, y equal to 5, and I am saying get me the result add x comma y, and then see out result. Okay, very simple code. We are taking two variables and giving it to the add function, and we are expecting an integer return, and we are printing it, right? Okay, so we have the result 10. But let's say if I pass in double values to this, let's say I'm passing double. Let's say I'm passing 2.5 and 2.5 to the function add, which returns an integer. Let's see what happens. So we get the result 4. You see, we would expect it to return us the number 5 because 2.5 plus 2.5 is 5. But because our return type is int and our variables are int and the addition operation is performed on int and int, there is some kind of typecasting being done here, and we are getting 2 plus 2 4 instead of 2.5 plus 2.5, which should have been 5, right? So I'm not able to use the same function to do operation on integer as well as double. So if I have to do a double addition, I have to declare a new function, and this time I will have to do double, right? Now when I do double here, I get the result 5, which is what I need. But for this, I have to write two methods, right? What if there is some way that I can write only one method, one function, and I can decide how to use it when I want to call the function, but not beforehand. So let's see how we can do this. That's where templates come in, right? Now I am saying I don't want to use predefine my data type, all these. I want it to be generic, so I can use templates. So this is how we'll use it, template, and we can give it a name. Let's say the commonly used uh, name is T. So I'm giving the name T here for my data type. So we are giving a variable for the data type. So let's see how we can use this. So wherever I said int, I will simply say ttt, and that's it. Because I said ttt instead of int, the compiler is able to decide what to put in this t based on the calls, based on who is making the call. So this time the call is being made on two double variables. X and Y are double and expected result is double. So let's see. And we get our result 5, which is what we need. Now can I change it back to int? Of course. Now without changing the function, I am able to use this for int as well. Let's see. Okay, I need to pass integers. Let's say I'm passing 2, 2. And we get 4. See, the same add function I am able to use for int and for double. This is the power of templates, right? I'm able to use the same function with different data types. The T is generic. You can put any name here. Instead of T, I can call it Z. It would still work. So we are giving a variable to the type itself. That's why templates come in, right? So these are function templates. So we discussed what are templates and we have seen the example of function templates. So we are able to reuse the same function for different data types, right? We can also do the same thing for classes as well. Let's see how we can do that. Let's remove all this. Let's say I have a class called A, and what A does is it has a private variable. Let's say int x, okay, and it has two methods, the getter and setter methods. One is setX. What this does is it takes in an int variable and it sets the x of the class, okay, and it returns nothing, so the data type of return is void. And let's say there is another method called getX. This does not take in anything, it will simply return this arrow x, right? A simple class. There is just one variable in it, and then there are two methods, setter method, getter method, okay? So if I want to use this, what I will do, I will simply say I've created an object for the class, and I can say a dot setX, give it 10, a dot getX, which will return me something. So I will just see out getX. Okay, let's run and see. So we get the value 10 here. So what is happening here? I created a new object. I've passed 10 to the setter method, and what setter method did is it took an integer and it just saved it to this x, and then I called getX. GetX is returning this arrow x, so getX is going here and getting the value of this. Okay, simple class. Now what if I want to generalize this class? I want to create this as a general setter getter class, right? I don't want to do int everywhere. That's when I can use templates. So how do we do that? So we say template, and we need to give the name to the data type. The data type, let's give it, let's say L. It doesn't matter, whatever. Let's say L. Now all I need to do is replace all int with L. Okay. And because I'm using templates, I need to tell the compiler what is this L. So compiler expects a data type to be given here in case of classes. So I need to tell that we are using int here. Okay. And it still works. Okay. Now I can do the same thing for double. I am saying double. Go and do double 2.5. It returns 2.5. I can do this for char as well. I'm saying don't put numbers now, put a character G, and we get back G. Okay. What if I have two variables? Let's say I have X, and let's say I have another variable called Y. But this time I don't want to use the same data type. Maybe I want to use a different data type. Now I can give it a different name. I can pass in two types here. One is type name L, another one is, let's say, type name K. And the second one will take the value data type K. Okay. And let's create a getter setter for K as well. So void set Y. This takes the data type K, and this arrow Y equal to Y. This is the setter method for Y. Let's do a getter method for Y. So what is the return type? K, get Y, and this simply returns this arrow Y. Okay. Now we have one setter getter for X, one more setter getter for Y, right? And in order to use this class now, I need to give it two data types. One is character, let's say another one is int. Okay. Now character is A, character is X, right? Set X is G, get X. We can do another set. A dot set Y. Y will be integer. I can give it, let's say 5. And I can do cout A dot get Y, right? So as you see, we get G and 5 back. So that way I'm able to generalize the whole class. I don't need to predefine my data types. I can use the classes or variables in general, functions in general, to be very, very generic and not type sensitive anymore. Okay. So those are class templates. Now let's discuss a couple of benefits of why we would use these templates. So first thing is obviously the code reusability. By writing one piece of code, I'm able to use it in different ways, right? That is code reusability. And second thing is flexibility. So think from a C++ point of view. Let's say C++ wants to give a package called stack or queue. So in stack, what happens is there are methods for adding elements to the stack, which is called push, and then removing elements for pop, right? So when we are saying push, we need to give it some parameter, right? And if I want to give some parameter to push, I need to know what data type it is expecting, right? But C++ in general would not have written stack library for each data type, right? There is no such thing called use this library called stack int, use this library called stack float or double, like that, right? There is only one stack. And anybody can use this stack, irrespective of the data type that they're using. They can store they can store numbers in the stack, they can store characters in the stack, they can store anything in the stack and perform these push and pop operations. Same goes for queue. And because I have generalized it, they must have used templates. If I write one stack library with templates, then I can publish it, and then anybody can use my library, right? So that is one of the biggest benefits of using templates. Okay. So whenever we are writing code as well, if you want to publish our code to some open source and we want others to use it, we can generalize it and keep it type insensitive so that anybody can use it. It's still strongly typed when it comes to compilation. We have to give it the right data types when we are using the actual library, but the code for writing the library will become very, very small and very reusable and flexible. Okay, that is the biggest benefit of templates. Okay. So this is the introduction to templates, guys. That's it for this video. Thank you so much for watching. If you have any questions, definitely ask me. Do leave a like if you found this helpful. Do leave a comment if you have any questions or suggestions. Don't forget to bookmark the playlist. Don't forget to subscribe to the channel. Don't forget to share it with your friends. Thank you so much for watching, guys. I will see you in the next one. Cheers.